So time delay, imagine you're driving this car, would be fun. And you're driving this car on a racetrack. But you're not driving this car directly, but you're actually sitting in one of these consoles and you have to drive this car through this console. And you're connected to the car via a network, an IP network with all its properties that it has. Then we usually call this side here where the human is called the master side, and then the robot side or the car side would be the slave. So I'll be using these terms throughout the presentation. Now to help you figure this, you're this person sitting in the car and you need to drive at 200 kilometers an hour through this track and not crash anymore. So if you look at this speed, it's about 55 meters in 1 second that you move. So an obstacle over here will approach you in about 1 second. Now, so that is a disturbance frequency, let's say, of 1 second. If we're adding now 1 second of time delay on your steering wheel, on your gas pedal, on your clutch, on your shift stick, and on your vision, how difficult would that be? So if the time delay is more or less the same than the disturbance frequency, it's a tough job. And since we are packet switched network, this is a digital system, and any digital system that sends data through geostationary satellites has packet loss. So essentially, you would be driving in a situation like this. So the take-home message here is the disturbance frequency and the time delay. If that's more or less the same thing, you're running into trouble. So we thought, okay, let's try this on ground. And a while ago in TEDx, we did a live demonstration here with a force-reflecting exoskeleton, which was located in Darmstadt in Germany. And here the robot at my laboratory in Nordwijk, and the task was to extract a pin and insert it back. So what's the disturbance frequency here? The moment you contact mechanical objects on a taskboard with a robot, the transition from free air to contact can be happening in less than a millisecond. So if you have time delays in the order of a millisecond, you're running into trouble. So you can have local impedance control here to mitigate some of these problems, but as soon as you close the loop and receive force feedback here, this is actually getting a hell of a job. So here we realized the first time what packet switch network means, and if you look at the video stream that was done here for the audience, you see what I mean. We expected a good network link, and we had dropouts in the order of 10 seconds, 15 seconds. So we had to develop all our software to be robust for connection loss, for packet drop, etc. And then we gained some confidence after we managed to do this packet placement. Actually in TEDx, we did a couple of more demonstrations. First one was just 600 kilometers, involving about 35 milliseconds. So that is about driving your racing car with 35 seconds delay on the steering wheel and on what you see. And then we moved actually further in some other demonstrations, which we did later with BBC. We shook hands with Buzz Aldrin, who was located in the UK, and we thought, well, now we are ready to move to space with this.